Hello students, today we are going to learn chapter 8, gravitation. In this, acceleration due to gravity, what is gravitational force, Kepler's law, potential, gravitational potential and escape velocity, these are all one by one. Let us see. Gravitation. Gravitation is the force of attraction between two bodies in the universe. For example, sun and the moon and table and the chair, like what are all the objects, the bodies which are there in the universe, the force of attraction between that two bodies. The gravity. We can say the gravity is the force of attraction between the earth and any object which is lying on or near the surface of the earth. You have to understand the difference between the gravitation and the gravity. Gravitation is the force of attraction between two bodies in the universe. The gravity, which is nothing but the force of attraction between the earth and any object which is lying near or on the surface. Understand? Free fall. The free fall, which is nothing but the motion of the body under the influence of the gravity alone is called a free fall. That we can say for the freely falling object. Acceleration due to gravity. The acceleration which is produced in a freely falling body under the gravitational pull of the earth, which we can call it as gravitation, acceleration due to gravity. So elaborately we'll see what is acceleration due to gravity. Newton's law of gravitation. The statement says, every particle in the universe which attracts every other particle with a force of attraction which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. See, you can consider two masses. We can take it as m1 and m2. These are the two masses. This is separated at the distance of r. We can take it as r. Now, these masses, the force is directly proportional to the m1, m2, mass 1 and mass 2, and F is inversely proportional to the square of distance between them. So F, which is equal to, we can say that G m1 m2 by r square. So here we can say G is the proportionality constant. So, G is the proportionality constant and the SI unit, which is Newton meter square, kilogram power minus 2, and CGS unit, which is dyne, centimeter square, gram power minus 2, and the dimensional formulae. The dimensional formula is m power minus 1, L power 3, T power minus 2. Right? Cavendish experiment. This experiment helps you to know or determine the value of G. See the diagrammatical representation. See this M1 and M2 are the two small lead balls of each mass M we have taken. And these are connected to the length L of the light rod. And the rod is supported by the vertical length of the quartz fiber. Now, these two large lead spheres which are connected here, that mass capital M, that are placed near the ends of the dumbbell on the opposite side. So the small spheres move towards the large ones under the gravitational attraction. So that we will get the force of attraction F, which is equal to G/mm by R square. See, the forces on the small spheres form a couple. This will exert a torque. See, this torque which deflects the rod and it is being twisted. Because of the twist, it will form a couple. The couple will produce or exert torque. So the torque, we know that tau, which is equal to force into perpendicular distance. That is the formula. So the deflecting force tau, which is equal to F into L, which is nothing but what? F is the force. L here we have taken the perpendicular distance, that is the length we have taken. So F value, as we know that, G/mm by R square into L. Here whenever the deflecting force which is acting on it, it will give equal opposite force, we said. That we can call it as the restoring force or a restoring torque. So this restoring torque, which is always directly proportional to the angle. So that we have taken here the restoring force which is equal to k theta. So we can compare these two forces or two torque. We'll get G/mm by R square into L, which is equal to k theta. So as we need G value, we need to determine the value of G, so that we are rearranging this equation G, which is equal to KQ by mml. The value is determined 6.67 into 10 power minus 11 Newton meter square kilogram power minus 2. That vector form of Newton's law, we can see that. See, these are the two masses m1 and m2, which are A and B we have taken. So it is separated at distance r. Okay. Now we can take r12 cap. It is a unit vector from A to B, and r21 vector, that is a cap. It is a unit vector, so that we have to represent r cap. So r cap 21 is a unit vector from B to A. So we can say here the force on A, that is F12 vector, it is a gravitational force which is exerted by B on A, that is F12. F21, which is nothing but the gravitational force exerted by A on B. Right. Now we can take, as we know that, F12 or F, that is the force of attraction between the two masses in the vector form, F12 vector, which is equal to minus of G m1 m2 r square r cap of 21. Here the negative sign shows that the direction of the force F12 vector is opposite to the r cap 21. That is, the gravitational force is the attractive nature. So that we can take the m1 attracts towards m2. So similarly we can say that F vector of 21, which is equal to minus of G m1 m2 by r square r12 cap. Right. So the implication of the vector form is here, as we said that r21, which is equal to what? Minus of r12. So that we can say the F vector of 21, which is equal to minus of F vector of 12. So thus the vector form of the law of the gravitation, which implies that the gravitational force of acting between the two particles form action and reaction, so that it will obey Newton's third law. variation in G, one by one we can see in that acceleration due to gravity at a height h above the Earth's surface. Before we are going to see this, the relation between G and G we must know. See the diagram, children. You can consider the Earth, that is to be the sphere of mass capital M, and the radius r we can give. Suppose a body of mass m which is lying on its surface. So, according to the law of gravitation, the force of attraction between the object and the Earth, F, which is equal to G mm by r square. And we must know here the force F produces an acceleration G. So, in the body of mass, because of the Newton's second law, force which is equal to what? mg. We are going to compare these two equations. mg which is equal to g mm by r square. Here we need to know about the value of g, so that g which is equal to, we can give g mm by r square into m. The m will get cancelled out. Then g which is equal to gm by r square. Okay. So this gives the relation between g and g. So next, mass of the Earth, that is g which is equal to what? We have given the relation gm by r square. So we need to know the mass m which is equal to g r square by capital G. By applying the value of G and the radius of the Earth and the gravitational constant value, we can get the mass value. So mass which is equal to, we can say that G value G which is equal to 9.8 into 10 to the power of minus 2, and into R value which is equal to 6.37 into 10 power 6, and it is whole square. Then divided by the G value which is equal to 6.67 into 10 power minus 11. By simplifying these things, we will get the value of m which is equal to 6 into 10 power 24 kilogram. So this is the mass of the Earth. So the average density of the Earth. The average density of the Earth, we can use the base formula with the help of mass which is equal to, what is the formula? Yes, volume into density. Right. As we know that mass m which is equal to g r squared by g. So volume which is equal to, the Earth volume which is equal to 4 by 3 pi r cube into the density which denoted by rho. By comparing mass and volume into density, we can get g r square by g which is equal to 4 by 3 pi r cube rho. We need the value of rho, that is density, which is equal to 3g by 4 pi g r. By simplified, we got the value of rho. So the rho value which is equal to 3 into 9.8 whole divided by 4 into pi value 3.14 into the g value is 6.67 into 10 power minus 11 into r which is equal to 6.37 into 10 power 6. Right. By simplified, you will get 5,500 approximately kilogram meter power minus 3. So this is the density of the Earth. Now, the factors on which G depends on the 4 factors which are altitude, depth, the shape of the Earth, the rotation of the Earth. One by one we can see. Before that, see, consider the diagram which is Earth to be the sphere of mass m and the radius r, center O. Then the acceleration due to gravity, we can say that G which is equal to gm by r square. So this is the first equation we can take, and GH, suppose the height which we can consider it means, then we can change the value of the r, then GM by r plus h whole square. By comparing these two equations, we can get GH by G, which is equal to GM by r plus h whole square and r square by GM. By simplifying this, we will get GH by G, which is equal to r square by r plus h whole square. Okay, so we will get now r square by r plus h whole square, which is equal to, we can write r square into 1 plus h by r whole square. By applying binomial theorem, we will get this. So that 1 plus h by r, we have written in the numerator, we will get 1 plus h by r power minus 2. This is the value for GH by G, which is equal to what? 1 minus 2h by r. Or else we can write GH, which is equal to G into 1 minus 2h by r. So this is the value of the earth, which is there, the factors of depending on altitude. Next we will see the depth. Now the next one is depth. You can consider the mass m for the earth and the gravity g. It's the radius capital R we have taken. So as we know that g value g, which is equal to gm by r square. Here we know that mass m, which is equal to volume into density. So that V, which is equal to 4 by 3 pi r cube into rho. Okay. So now we are applying the value here. See G, which is equal to capital G, mass, that is volume into density, 4 by 3 pi r cube rho whole divided by r square. So G value, which is equal to 4 by 3 pi G r into rho. Okay. So this is the value for G. So we need to know about the depth. So for the depth, we have to take GD, which is equal to G m dash whole divided by G minus, R minus depth, radius minus depth whole square. Here m dash, which is equal to 4 by 3 pi, instead of r cube, you have to write r minus d whole cube. Here you are applying the value, you will get GD value is G 4 by 3 pi r minus d whole cube whole divided by r minus d whole square. Got it? Now you will get the value for GD, which is equal to 4 by 3 pi G r minus d into rho. Right? So we'll get this value for GD. So GD is what we said? GD, which is equal to 4 by 3 pi r minus d G into rho. Here we are comparing GD by G. Okay. GD by G, which is equal to 4 by 3 pi G r minus d into rho whole divided by 4 by 3 pi G r into rho. Here by simplifying this, you will get GD, which is equal to G into 1 minus d by r. So this is the value for the depth, effect of shape of earth on G. See the diagram, children. Earth is not actually a perfect shape of sphere. It is flattened at the poles, the bulge out at the equators, right? So the equatorial radius, we can take it RE of the Earth, is greater than the polar radius RP, that is about 21 kilometers. See, according to the gravity of the Earth's surface, G, which is equal to what? Gm by R square. That is, G is inversely proportional to R square. So as RE is greater than RP, so that GE is less than GP. Right. So this is the value of G is minimum at the equator and maximum at the poles. So that is why the weight of the body increases when it is taken from the equator to the poles. So far we have learned from this session about the introduction of gravitation, Newton's law of gravitation, and the important features of the gravitational force, the relation between G and G, and the factors which are all depending on G, that is altitude, depth, shape. Due to all those things, we have learned elaborately through this session, students. Hope you will understood. Thank you, students.